All right, let's try this video lesson thing. So I am recording a little bit of trig review for you guys for our OSSLT day. Right angle trig review and non-right angle trig review, all review from grade 10. So right angle trig is a length or an angle that you calculate using good old SOHCAHTOA from grade 10. SOHCAHTOA is an acronym to help us remember the formulas for trig. So, standing for sine is opposite over hypotenuse. SOHCAHTOA standing for cos is adjacent over hypotenuse, and TOA, tan, is opposite over adjacent. So SOHCAHTOA is only used for a right angle triangle. To use it, you either need to know two side lengths, and then you can calculate an angle. Or if you know an angle and a side, then you can calculate another side length. These three trig formulas, sine, cos, and tan, the SOHCAHTOA part, are known as the primary trig ratios. So one of the things you need to remember, we've already been talking about, is theta is used to represent an angle. We need to remember when we're labeling our triangles, capital letters are used for corners or vertices, and small letters are used for the opposite sides. So if this top corner is corner A or vertex A, then the side that's across from it is side little a. And if the right angle is the corner B or vertex B, then the side across from it is little b, and so on, to label your triangle. Other things you need to remember when we're talking about sides that are opposite, adjacent, and hypotenuse for the formulas, we need to remember that those are relative to angles. Hypotenuse is the easiest one because the hypotenuse is always across from the right angle. It's the longest side of the triangle. The other two are determined by whatever angle you're looking at. So if I have angle theta, side C is opposite to angle theta, well, side A is adjacent to angle theta. But if I switch my angles and I look at angle alpha, I believe that is, then this is opposite to alpha, and this is adjacent to alpha. So opposite and adjacent depend on what angle you're looking at in the diagram. The hypotenuse is always in the same location across from the right angle. So important information when you go to use those formulas. To use the primary trig ratios, 4 things. Identify the angle that you're either given in the diagram or that you need to calculate. Identify the sides that you're given in the diagram or you need to calculate. Choose the right formula, sine, cos, or tan, and then solve. So I'm going to look at these 2 questions. Solve for the variable indicated. So in this first question A, it's asking me for solve for side x. So I've identified what I need to solve for. I need to choose sine, cos, or tan. So to choose sine, cos, or tan, I need to know what information I was given. So the information I was given is the hypotenuse and this angle, and side x happens to be adjacent to that angle. So now that I've labeled everything and identified it, I know the formula I have to use has adjacent and hypotenuse in it. And the one that uses adjacent and hypotenuse is cosine, because cos of an angle is the adjacent side over the hypotenuse side. So when I fill in my formula, there's always 3 things, and one of them I don't know. So in this case, I know the hypotenuse, I know an angle, but I'm missing a side. There's the 3 things. So I'm going to fill it into my formula. Cos, the angle always goes with sine, cos, or tan. So I have cos of 47 degrees. Oh, I don't think I'm going to have quite enough room there. Let me move this over. Cos of 47 degrees equals the adjacent side. The adjacent side is the one with the x, so I put x instead of adjacent. And the hypotenuse side is 15, so it goes on the bottom because the formula has the adjacent in the numerator, hypotenuse in the denominator. To solve this, we solve by doing the opposite operation. So I want to know what x equals. Instead of dividing by 15, I move it over to the other side and do the opposite of dividing by 15, which is multiplying. So to figure out x, I just have to do 15 times the cos of 47 degrees. And I need to get my calculator to do that. Make sure when you're using your calculator that it is in degree mode, or you'll get some strange answers. So 15 times cos of 47. Also be careful that you know how to use your calculator. That means some calculators you can type it in exactly as it is, 15 times cos 47. Some calculators are reverse entry for trig. So you have to do 47 cos, reverse entry. So make sure that you got your calculator figured out and get the same answer that I did, 10.2 centimeters. All right, B, same thing. There's my diagram. Here's the angle I was given. Identify my sides. Well, if it's across from the angle, then it's opposite. If it's across from the right angle, then it's hypotenuse. So the formula that use opposite and hypotenuse is sine. SOHCAHTOA. Sine is opposite over hypotenuse. So my three things: angle, hypotenuse, side, opposite side. So I fill in the angle with sine, 32 degrees. The opposite side is 6.8, and the hypotenuse is unknown. Be careful, this question's a little bit different than the first one. In the first one, the unknown was in the numerator. In the second one, the unknown is in the denominator. Mathematically, we're doing the same thing. We're doing the opposite operation. Mathematically, instead of dividing by d, I will multiply by d, which means I'd have d times the sine of 32, but I'm still no closer to getting an answer. I have to do another step. To get d by itself, instead of multiplying by sine 32, I would have to move the sine 32 over and do the opposite, which is divide. So I would end up doing 6.8 divided by 32 sine, or sine 32. 6.8 divided by, and I get about 12.8 centimeters. Make sure you remember to put your units on there because it is a length. Sometimes when you're learning trig, you take a shortcut and you don't always show this step. You just remember that these two switch places, whatever makes the most sense to you so that you're getting the right answer. All right, next part, solving a triangle. Remember that to solve something means you want to calculate the length of all the sides and all the angles. So there are a few things we can do to achieve that goal. We're going to start the same way as we just did. I'm missing an angle, but I've identified an angle. The side across from that angle is the opposite, and the one right beside it is the adjacent. And I'm missing the hypotenuse because the side across from the right angle is not labeled. So right now, if I'm looking at opposite and adjacent, that would be the tan formula, TOA, tan theta equals opposite over adjacent. This time in my question, I don't know what the angle is. So I've got an unknown angle, I've got side length, and another side length. So I have an unknown angle, which means I will leave the unknown there, I won't put a number. And then I fill in my sides in the right spots. So the opposite side goes in the numerator, and the adjacent side goes in the denominator. Now, to calculate an angle is a little bit different than to calculate a side. To calculate an angle, you must do the inverse function, inverse tan, inverse sine. And there is also inverse sine and inverse cos, depending on what formula you're using. So to calculate my angle, and you'll find those buttons right above sine, cos, and tan in case you've forgotten. I'm going to do the inverse tan of 12.5 divided by 8.4 all in one step. So I have no rounding until the very end. My calculator turned on again. All right. So literally, some of you will be able to type that in exactly as it is, inverse tan, bracket 12.5 divided by 8.4, and you'll get your answer. Depending on your calculator, if it's reverse entry, then you'll have to do the dividing first and then your inverse tan. Make sure that you're pressing your shift button or your second function button to access the inverse tan. So I'm getting about 56 degrees for that angle. When you're solving a triangle, there are other things you can use other than trig. For example, now that I know this angle is 56 degrees, I know something about the angles in a triangle that will help me shorten my calculations. I should note they all add up to 180. So if I want to figure out my last angle, I'm going to call it x. All I would need to do is take the two angles I know and subtract them from 180, and that will help me figure out my missing angle of 46 degrees. So now I know all the angles in a triangle. In addition, when you're solving, to knowing angles, you can also use Pythagorean theorem to calculate a side length. To use Pythagorean theorem, you need to know the lengths of two other sides. And it only works for right triangles. So I know two sides of my right triangle. What I'm missing is the hypotenuse. Remember, good old Pythagorean theorem way back, grade 8, grade 9, grade 10. Oh, and here it is in grade 11 again. Pythagorean theorem really is just side squared plus side squared equals the hypotenuse squared. So if I go back to my triangle, that would mean I'd have 8.4 squared plus 12.5 squared is going to equal my hypotenuse squared. And you can give the hypotenuse a letter if you want. I'm just going to work with the hypotenuse right now. And I'm going to calculate that answer on my calculator. 8.4 squared plus 12.5 squared. And I've got 226.81. But I don't want to know what the hypotenuse squared is. I just want to know the length of the hypotenuse. So I'm going to square root it. And because length is positive, we don't have negative lengths. We only look at our positive square root value. So I've got about 15.1 for my hypotenuse. And I think that was centimeters. Meters, actually. So meters. So there is a quick review of SOHCAHTOA. If you want, you can pause that now and try some of the questions on page 247, or you can watch the whole video and then try the trig altogether. I'm going to go on in a few minutes and do sine law and cosine law as well review. Okay, if you pause that, then you maybe have tried some of the SOHCAHTOA questions. We're going to look at sine law and cosine law. So the sine law and cosine law are used to calculate unknown lengths and angles when you have a non-right triangle. So the ones we just talked about were right triangles. These are non-right triangles. The sine law is on the left here. Two versions, one for sides and one for angles. And the only difference is they're flipped upside down. So the sine law is easiest to use if you put what you don't know in the numerator. And that's the only reason I flip them upside down. It's just easier to solve if what you don't know is in the top, in the numerator. Cosine law, much more complicated formula. One for sides and one for angles. So to use the sine law, there's certain information you need to know. You only ever use two at a time, and you can use any two at a time to make it work. When you're using two of those, you need to know three pieces of information. So to calculate a side length, you need to know two angles and one side. Or to calculate an angle, you need to know two sides and one angle. But there's a catch. For both situations, you must have a pair. And what I mean by that is you have to have an angle and a side that are across from each other, that are opposite each other in the triangle. Don't think I'm going to be able to fit that. I'm going to have to scroll the screen. So you've always got to make sure that when you're using SOHCAHTOA, that you have a pair, an angle and a side that are across from each other. This is why the formulas are labeled capital A, little a. Remember our diagram earlier, the side and the angle across from each other. The angle has the capital letter and the side across from it has the little letter. All right, cosine law. To use the cosine law to calculate a side, you need to know two sides. Whoops, can't write at this time of day. There we go. Two sides and an angle. But there's something special about that angle as well. See how that's little a and that's capital A. Same thing applies. If I'm solving for a side using the cosine law, the angle that I use has to be across from the side I'm trying to figure out for the formula to work. So the angle you use must be opposite the side you're calculating. And for angles, you need to know all three sides. I think I need to make myself some more space here because I want to say one more thing. The way you know that you have the angle opposite to the side that you're calculating is that you have a contained angle, it's called. Yeah, I need to make more space. Let me see if I can group this and slide it down. Look at that. Perfect. So the way you know that you have the right information to use the cosine law is you have two sides with a contained angle. That means the angle is between them. All right, I think I have touched on everything. So to use the sine law and cosine law, Calculate the indicated unknown. So determine A. Oh, little a. So little a, there's capital A on the corner. This side is little a. So that's the first thing I'm doing, picking out the side, picking out the information. Next thing I notice, hey, I've got an angle and a side that are across from each other. That is a sure sign that I can use, haha, no pun intended, the sine law. So when I use the sine law, remember when I'm calculating a side length, I'm going to put them in the numerator. A over sine A equals, in this case, side C over sine C. So I don't know what side A is, but I know its opposite angle is 70 degrees. I do know side C, 6.8, and sine of 80. Make sure you're always putting these pairs together that are across from each other when you use your formula. See how they stay together? The side and the angle that are across from each other. So now to solve it, I'm going to do the opposite operation. Instead of dividing by sine 70 of 6.8 divided by sine 80, and the opposite of dividing by sine 70 is to multiply by sine 70. And I'm going to type that all into my calculator in one big step. So 6.8 divided by trig times 70. I got 6.5 for my side A. All right, determine G. G is an angle. So first thing I notice in my picture, I've got a lovely pair opposite each other. Whenever I have a pair opposite each other, I am going to do the sine law. So I want to calculate an angle, so I'm going to put sine G in the numerator over the side across from it, which is 7 meters. And I'm going to put the angle in the numerator, so I have sine 50 over the side across from it, which is 12.5. Angles are a little more complicated, but they're very similar. You got to remember two things about angles. Remember, to do an angle, you need to do the inverse to calculate the answer. So I'm going to do two steps here. I'm going to get the letter by itself, which means instead of dividing by 7, I'm going to move it over here and I'm going to multiply by 7. But then the last step, so that I don't do a whole bunch of rounding, is I'm going to do sine inverse of all of that. So I'm going to do the inverse sine of that calculation. If you have a decent calculator, you should be able to do that all in one step. Enter it just like it is right there. So let me type up what that answer is. What have I got here? Perfect. I have 25.4 meters. All right, two more quick ones, and then you guys are on your own. So next one, oh, I don't have a side and angle across from each other, but I do have a contained angle, an angle that's between two sides. When I have a contained angle, that's when I'm going to do cosine law. But wait a minute, it tells me to calculate C. There's a problem here. I think that's supposed to be A. I think I have a typo. Yep, we're going to calculate A. So back to what I was saying, angle between two sides, cosine law. So cosine law, A squared B squared plus C squared minus 2BC cos A. What's important? These two, doesn't matter what order you put them in as long as you put them each in the formula. It's important to remember, if I'm calculating A, that the angle I use is across from it. So when I fill in my formula, I'm going to have 8.5 squared plus 4.7 squared minus 2 times 8.5 times 4.7 cos 56. And that's my A squared. So when I type it into my calculator, I'm going to type it in all in one step. 8.5 squared plus 4.7 squared minus 2 times 8.5 times 4.7 times cos 56 equals, and I'm going to get a big long decimal number. So I'm not going to write down the whole decimal number, but I'm going to leave it on my calculator and take the square root of the whole thing, not the rounded number. So that I find out my answer is about 7.0 centimeters. Guess what the last one is? Using the cosine law for an angle. So it wants me to figure out angle U. So my cosine law, cos U equals, when I fill in my cosine law, I'm just going to go back up to the formula for a minute. Where is my formula? Oh, I lied. My formula is on this side. One other thing I want to point out. Whatever angle we're calculating using the cosine law is the side that gets subtracted. So when you're filling in your formula, don't worry about A, B's, and C's. Just remember the side that gets subtracted is the one that's across from the angle you're trying to figure out. Oops. So when I go back to my last question, the side I want to subtract is the one across from the angle I'm trying to figure out. So I'll fill in the other two sides. 8.1 squared plus 5.9 squared minus 9.2 squared over 2 times 8.1 times 5.9. And remember about angles. Whenever you're calculating an angle, you have to do the inverse. So ultimately, to get angle U, I'm going to do the cos inverse of this. Whoops, got my decimal in the wrong spot. And when I do the cos inverse of this, I have to be really, really careful on my calculator to make sure that I've done it correctly. I'm going to do the answer, and then I'll give you some tips on your calculator about how to do that. Give me a sec here. If I could hit the right buttons. There we go. 8.1. I think I may have to do it again. I think I hit a wrong button. Oh, that might work out. I got about 80 degrees. I'm just going to double check that before I give you some false instructions. Make sure I did it right. Okay, 2 times. Uh-oh, I got a different answer that time. I hate when that happens. Told you this was complicated. 0.1, third time's a charm. That's 5.9 minus 9.2. Oh no, that one's not working at all. Okay. Good teacher would have had this all done on a piece of paper instead of doing it while she was teaching it. Squared equals that. I think I got it this time. I was right the first time. Yay me. Okay, tips for using your calculator. You have to make sure, if you're going to enter it all at once, that you get the answer to the numerator. So you're going to put brackets around it, then hit divide, and put brackets around the denominator. I tend to use time signs instead of brackets when I enter it so that I don't have so many brackets to deal with. That's the best tip. But what you have to understand is you need the answer to the top divided by the answer to the bottom to get the right angle. All right, I think I have finally finished. That was a little bit longer than I was anticipating. We'll check on Schoology for what else you will need to do. Good luck.